Ready for one of the easiest topics in every chemistry class from Chem 1 through organic chemistry? It's energy diagrams. Let's talk through all of the parts of these diagrams so that you can celebrate when you see one of these on your next exam. So first of all, our x-axis is going to represent the reaction coordinate. It's basically the progress of the reaction. This is going to help you if you think of it as a progress. You're going to remember we always start with reactants, we end with the products. The difference in the energy between the reactants and that highest peak is known as the activation energy. That is the hump that you have to get over as you're transitioning from the reactants to the products. The difference in the energy between the reactants and products, that is your enthalpy. If you have a positive enthalpy, that is endothermic. If it is negative, that is exothermic. So let's figure out what this graph represents. So let's say our products are at 50, our reactants are at 75. That is a negative 25. This is an exothermic reaction, and these are more common. If we have an endothermic reaction, we're going to have a higher energy of the products compared to the reactants and a positive enthalpy. If you see this dashed line, that represents a catalyzed reaction. A catalyst changes the reaction pathway so that it has a lower activation energy overall. But unfortunately, not all reactions are just a single step. So let's look at a multi-step profile. You'll notice the axes labels have not changed because we're still measuring the same quantities. The difference is we're going to have multiple peaks to represent the different elementary steps of that reaction. What you're going to look for first is the one that has the highest point, the highest transition state, right? That is going to represent the rate determining step. It is also known as your slow step, right? Because it has the highest activation energy, or the difference between the reactants and that transition state. And that's something I should also clarify. The difference between the transition state, the highest point on these peaks, and the activated complex. The activated complex represents all of the range of possible configurations as we're shifting from reactants to products, versus the transition state is just the highest energy. In the opposite position, we have the intermediates. Those are the substances that are formed in these elementary steps and then used up. Follow Chem with Corinne for more straightforward chemistry, and drop a comment if you'd like to request my next tutorial.